Today, we're going to pull back the curtain on something called polyglot persistence. Now that might sound a little academic, but trust me, it's the secret weapon that powers pretty much every complex, high-performing app you use. And once you get it, you're going to start seeing it everywhere.
So think about a giant e-commerce site for a second. It's got to act like a bank, right? Processing your payments with perfect 100% accuracy. But it also has to be a massive library, letting you instantly search through millions of products. And on top of all that, it needs to be a super fast cashier, managing your shopping cart without a single hiccup. How on earth does one system juggle all of that at the same time?
You know, for a long time, the thinking was, let's just find one big, powerful database that can do everything. But that's kind of like trying to build a whole house using only a hammer. I mean, sure, you can bang some nails in, but what happens when you need to cut wood or screw in a light bulb? It gets really clumsy, really fast.
The thing is, these jobs are basically fighting with each other. Your financial transactions demand absolute, unshakable consistency. No mistakes, ever. But managing a shopping cart for millions of people at once? That needs pure, raw speed. Then you've got product search, which is all about complex text analysis, and business reporting, which has to crunch mountains of historical data. No single database is a rock star at all of those things.
And that brings us to the big idea, the solution to this whole puzzle. It's a philosophy called polyglot persistence, and at its heart, it's actually a pretty simple concept, but it is so powerful. Use the right tool for the right job.
So what is it really? Well, it's the practice of using several different specialized data stores, each one perfectly tuned for a specific task, all working together inside of one single application. So instead of trying to force one database to be a jack of all trades, you let each part of your system use the technology that it's best at.
The absolute best analogy for this is a professional chef's kitchen. You'd never see a top chef trying to slice bread, fillet a delicate fish, and chop dense vegetables all with the same giant meat cleaver, right? Of course not. They've got a whole set of specialized knives. Polyglot persistence is just applying that exact same expert logic to how we build software.
Okay, so enough with the theory. Let's see how this actually works in the real world. We're going to build out our e-commerce app piece by piece, and we'll pick the right AWS tools for each part of the job.
First things first, we've got to handle the money. This is the most critical piece. When a customer places an order or makes a payment, there is absolutely zero room for error. We need what's called ACID compliance, which just means the data has to be totally, completely reliable. Data integrity here is everything.
So what's the best tool for that job? Well, it's the same one that banks have trusted for decades, a relational database. It is built from the ground up for strict consistency. In the world of AWS, we're talking about something like Amazon Aurora or Amazon RDS.
All right, now what about things like the shopping cart, or just remembering who you are as you click around the site? This kind of data changes all the time, and it needs to be fetched in milliseconds for potentially millions of users at once. It has to be incredibly fast and able to scale up like crazy.
For this job, a NoSQL key-value store is the perfect choice. It's designed for super simple, super fast lookups at a massive scale. And our AWS example here is an absolute powerhouse, Amazon DynamoDB.
Okay, next up, the product catalog. You know how it is. A user types red running shoes size 10 into the search bar, and they expect instant, totally relevant results from a catalog of millions of items. This isn't just a simple data lookup, it's a really complex text search that involves filters, rankings, and even suggestions.
A regular database would absolutely choke on a query like that. The best tool here is a dedicated search engine, and on AWS, that job belongs to the Amazon Open Search Service, which is purpose-built for exactly this kind of powerful text-based searching. And finally, you've got the business side of things. People in marketing and finance need to ask big questions like, hey, what were our total sales for running shoes in the Midwest last quarter? This means running huge, complex queries over months or even years of historical data, and you have to do it without slowing down the live website for actual shoppers.
This is the classic job for a data warehouse. It's a special kind of database optimized for exactly this kind of analytical workload. So here, the right tools would be something like Amazon Redshift, or maybe even storing raw data in S3 and querying it directly with a service like Athena. And look at that. When we bring it all together, the whole architecture just becomes crystal clear. It's not one database struggling to do everything poorly. It's a whole team of specialists. Orders and payments, they go to Aurora. Shopping carts, they use DynamoDB. Product search is handled by OpenSearch, and all the analytics run in Redshift. Each system is playing to its own unique strengths. It just makes sense.
Okay, so this all sounds amazing, right? But, and you knew there was a but, this power does not come for free. When you adopt a polyglot approach, you're also introducing a new set of challenges, and it is so important to be aware of the trade-offs.
Suddenly, you have way more systems to monitor, to patch, and to secure. Your team can't just be experts in one database anymore. They need diverse skill sets. You have to really think about how data is going to move between these different systems and stay in sync. And yeah, if you're not careful, the costs can definitely add up. So how do you get all the benefits without getting totally buried in all that complexity? Well, the key is to be deliberate. You need to be intentional. So here's a simple 3-step framework for adding a new data store to your system responsibly.
So here's the deal. Don't just add a new technology because it's the hot new thing. First, you have to justify it. Really prove that your existing tools just can't do the job. Second, assess the full impact. What's the operational cost? What new skills will your team need? And finally, if you commit, you have to standardize it. Create clear rules and patterns so that everyone on the team uses the new tool in a consistent and effective way.
I love this way of thinking about it. Every new piece of technology you add comes with a complexity tax. As an architect, as a developer, your job is to make absolutely certain that the benefit you're getting is worth the price you're about to pay. And I'll leave you with this one last thought to chew on. Chances are, if you really look at the systems you work on, you're already using multiple data technologies. You're already a polyglot. So the real question is it an intentional, well-designed strategy, or did it just sort of happen? Are you managing your architecture by design or by accident?